Hello, folks. Today we have found 512 new AI papers on ArXiv. Here are some that stood out to us, and hopefully you'll find them interesting too.
Researchers at ETH Zurich and Google DeepMind found sharpness-aware minimization, SAM, great for image tasks, fails in NLP. Why? SAM focuses on logits, not function geometry. They created functional SAM, improving validation metrics across models spanning 3 orders of magnitude, even outperforming AdamW. Researchers at Tsinghua University and Huawei Noah's ArcLab, along with a team from other universities, created a new world model. It's pre-trained on a massive dataset. 1.3 million trajectories from 80 different environments. This lets it handle varying sensors and actuators better than previous models. Researchers at Tsinghua University developed Transolver++, a new neural PDE solver. Unlike previous models limited to hundreds of thousands of points, Transolver++ handles millions. It uses optimized parallelism and a local adaptive mechanism to learn physical states. This leads to over a 20% performance boost in million-scale industrial simulations. Researchers at the University of Edinburgh and Microsoft studied how student neural machine translation, NMT, models inherit memorization from their teachers using sequence-level knowledge distillation, SEQ-KD. They found students memorized 57% more than baselines and hallucinated more. Researchers at Google developed skOwn, a new method to boost language model performance. skOwn adds embeddings for frequent n-grams, stored in cheaper memory. A 1B parameter model using skOwn outperformed a 1.9B parameter model using half the inference flops. Researchers at UIUC and Stanford, along with a team from NVIDIA Research and Technion, studied a new reinforcement learning model. They gave rewards after segments of an episode, not just at the end. With binary feedback, increasing segments drastically improved learning. With some feedback, it didn't help much. Researchers at Sun Yat-sen University and Microsoft, along with colleagues from UC Merced, developed BD-Diff. It's a new image deblurring model using blur-decoupled learning. Unlike other methods, it uses unpaired blurry images to learn blur patterns separately, improving performance on unseen blur types. On the REDS dataset, it achieved a 63.91 MUSIQ score. Researchers at UC Berkeley and MIT, along with teams from NVIDIA and Tsinghua University, developed Sparse Video Gen, SVG. SVG speeds up video generation by 2.33x by using the hidden sparse nature of video data. This is different from previous work focusing on text data. Researchers at EPFL and TU Dresden used deep learning to predict cell cycle stages from bright field images. Their sequence models, trained on 1.3 million images, outperformed single-frame methods, accurately predicting transitions like G1/S within 1-hour resolution. Researchers at MIT introduced harmonic loss, a new way to train AI models. Unlike cross-entropy loss, harmonic loss is scale-invariant and converges faster. In tests, harmonic models generalized better with less data and produced more interpretable representations. For example, in-context learning, they achieved 100% explained variance using only 2 principal components. Researchers at Gen AI and Tel Aviv University, along with other institutions, created Video JAM. It improves video generation by adding a motion prior. Trained on just 3 million videos, it outperforms other models in motion coherence. Researchers at MIT CSAIL and Autodesk Research developed GoFlow, a new method for training robots. It uses normalizing flows to learn how to handle uncertainty in robot environments. This improves robot performance in 6 simulated and 1 real-world task compared to other methods. Researchers at Tsinghua University and Galaxia AI, along with a team from other institutes, developed VR Robo. It uses 3D Gaussian splatting to create realistic robot training simulations. This lets robots learn from RGB images only, achieving 100% success in some simulated tests. Researchers at MIT developed a new method for adapting multimodal embeddings. It uses contrastive learning on frozen embeddings, achieving up to a 20% F1 score increase with minimal computational cost. Running in minutes on a CPU. Researchers at the University of Wisconsin-Madison and Carnegie Mellon University, along with others, show how transformer models can self-improve. They iteratively generate their own training data, solving problems far beyond their initial training. For example, a model trained on 1 to 16-digit addition generalized to over 100 digits. Researchers at Shanghai Jiao Tong University and Harvard University, along with a team from several other institutions, developed Flux-SR. This new one-step diffusion model for image super-resolution uses a 12B parameter model and a clever technique called flow trajectory distillation to improve image quality without the usual computational cost. Researchers at Carnegie Mellon University and Google Research studied how different text embeddings affect language model training. They created a new way to measure how well embeddings group similar data points. Using a 1.7B parameter model and the PILE dataset, they found that a simple embedding method surprisingly outperformed more complex ones. Researchers at MIT and Singapore University of Technology and Design, along with a team from other institutions, developed Satori, a 7B parameter LLM. Satori uses a new chain-of-action thought method and a two-stage training process to perform autoregressive search without external help. It achieved state-of-the-art results on math problems using only 10,000 samples for initial training. Researchers at Stanford University and Toyota Technological Institute at Chicago improved multilingual speech recognition. Their new CTCDRO method reduces the worst language error by up to 65.9% and average error by up to 47.7%. It tackles issues with the connectionist temporal classification, CTC, loss scaling with input length. Researchers at Tsinghua University and Ant Group created Dual Flow, a new method for multi-target adversarial attacks. Unlike previous methods, it's instance-agnostic, using a pre-trained diffusion model and a fine-tuned velocity function. This boosted transfer attack success rates from inception-v3 to RESNET 152 by 34.58%. Researchers at the University of Tokyo and Delft University of Technology created Unigaze. It uses self-supervised pre-training on 1.6 million facial images to improve gaze estimation accuracy across different datasets. This is a big improvement over previous methods that used much smaller datasets. Researchers at Brown University and Meta Reality Labs created UVGS, a new way to represent 3D objects. They use spherical mapping to turn unstructured 3D data into structured 2D images. This lets them use existing 2D image models for tasks like generation and compression, achieving over 99% compression in some cases. Researchers at the University of Waterloo and HKUST, along with other institutions, developed AceCoder. It uses automated test case synthesis to improve reinforcement learning for code generation models. A 7B parameter model saw a 25% improvement on Human Evil Plus after just 80 optimization steps. Researchers at UC Santa Cruz and Johns Hopkins University, along with a team from 3 other institutions, developed UD-Mamba. This medical image segmentation model uses pixel-level uncertainty to guide its scanning, improving accuracy. On the ISIC 2018 dataset, it achieved an 89.15% DSC, outperforming other methods. Researchers at ETH Zurich developed a new method for training robots. It uses memory augmentation to improve how well robots adapt to new tasks. This lets robots handle 8 different locomotion tasks with zero-shot generalization and better sample efficiency than other methods. Researchers at the Université Libre de Bruxelles and Athena Research Center, along with others, developed FRAUD-RLA, a new reinforcement learning attack against credit card fraud detection. Unlike previous attacks, FRAUD-RLA doesn't need access to transaction history. It focuses on controllable features, achieving high success rates even with limited knowledge. Researchers at MIT and IBM, along with colleagues from the University of Tübingen, developed M-Whisper Flamingo. This multilingual audiovisual speech recognition (AVSR) model uses a new decoder modality dropout technique. It improves noisy speech recognition in 9 languages, achieving a 10.6% relative WER improvement over audio-only models. Researchers at Tsinghua University and Nanjing University, along with other scientists, developed CRISP-BFN, a new crystal generation method. It uses a periodic Bayesian flow, achieving approximately 100x speedup compared to previous methods, 10 vs 2000 steps, on the MP20 dataset. This new approach addresses the periodic nature of crystal structures. Researchers at the University of Zurich and ETH Zurich developed SIGS, a new neurosymbolic AI method for solving differential equations. Unlike traditional methods, SIGS uses formal grammars and a variational autoencoder to find analytical solutions. In tests, SIGs often converge to the exact solution in just one iteration, outperforming other methods by orders of magnitude. Researchers at the University of Illinois Urbana-Champaign and OpenAI, along with colleagues from Google Research and Stanford, developed a new contextual bandit algorithm. It uses Catoni's estimator for robust reward estimation, achieving variance-based regret bounds with only logarithmic dependence on the reward range, even when variance is unknown. Researchers at Peking University and Tencent, along with a team from Tsinghua University, developed LongDPO. This new method improves long-form text generation in LLMs by using process supervision with Monte Carlo tree search. It also adds a global memory and external critiques, boosting performance by about 8% on texts over 4,000 words. Researchers at MBZUAI and the University of Tokyo, along with other teams, found that larger language models, LLMs, are more human-like than previously thought. By analyzing internal layers, they showed that larger LLMs better match human reading behavior and brain activity across 15 datasets. In 80% of cases, internal layers outperformed the final layer. Researchers at Google DeepMind and Gatsby UCL improved diffusion models. They learned the full data distribution instead of just the average, using scoring rules. This lets them generate high-quality images with far fewer steps. Researchers at Peking University developed a new way to understand large language model (LLM) values. They created a 5-factor value system using a method called GPLA. This is different from using human-based value systems. GPLA uses 693 LLM subjects to build a more accurate model. Researchers at Rutgers University and Carnegie Mellon University, along with a team from 3 other institutions, found unusually large numbers, massive values, in the query and key parts of LLM's self-attention. These values are crucial for understanding context, not just memorized facts. Disrupting them caused a huge drop in performance on contextual tasks, like IMDb sentiment analysis, from greater than 94% to single digits. Researchers at Tsinghua University and Real AI, along with a team from 3 other institutions, developed STAR. This framework improves LLM safety by adding introspective reasoning. Unlike previous methods, STAR uses chain-of-thought reasoning and a special search method to identify and avoid risks. LMA's safety improved by 15% compared to the best existing method. Researchers at Google Research and UC Berkeley studied how scaling up the number of answers a language model generates improves its reasoning. They found that simply increasing the number of samples and improving the verification process significantly boosted accuracy, with Gemini version 1.5 Pro's AIME score jumping from 4/15 to 8/15. Researchers at Peking University explored graph generation models. They found existing models struggle to accurately generate complex substructures. A new evaluation metric based on subgraph counts revealed that even simple structures like 7-line graphs are poorly generated. Using more expressive GNNs improved results. Researchers at Peking University developed equivariant noise GNN, ENGNN. Unlike previous methods, ENGNN uses noise as input, but is invariant to noise channel permutations. This improves generalization. Adding noise alone decreased accuracy by 32% on average, but ENGNN improved accuracy by 1% and 33% compared to vanilla and noisy MPNNs respectively. Researchers at MIT and Red Hat developed a new way to improve large language models, LLMs. Instead of searching for the best answer, they use probabilistic inference with particle filtering. This method is 4 to 16 times faster than other methods and lets smaller models match or even beat larger ones. One small model even outperformed GPT-4 with only 4 attempts. Researchers at Duke University and Arizona State University, along with colleagues from Stanford, developed Hamming attention distillation, HAD. HAD binarizes parts of the transformer's attention mechanism, achieving a 79% area and 87% power reduction in custom hardware, while only losing 1.78% accuracy on GLUE. Researchers at Wellesley College and the University of Texas at Austin, along with other institutions, created a new benchmark for large language models, LLMs. It uses general knowledge puzzles, unlike existing benchmarks. OpenAI's On1 model scored 59%, while DeepSeek R1 scored only 35%. Researchers at Fudan University and Peking University, along with colleagues from HKUST, developed CE-LoRA. This new algorithm speeds up the fine-tuning of large language models, LLMs, by 3.39 times compared to LoRa. It does this by improving how activation gradients are calculated during backpropagation. Researchers at MIT and TU Munich studied position bias in transformers. They used a new graph-theoretic framework to show how attention masks and positional encodings create bias across multiple layers. Their findings show that deeper layers amplify bias towards earlier tokens. Researchers at the University of Tokyo and New York University, along with colleagues from other institutions, modeled large language model, LLM, reasoning as a metastable Markov process. This new framework shows how inference time search improves reasoning, reducing the expected time to solve problems by a factor related to the probability of hard reasoning steps. Researchers at Texas A&M University and Caltech, along with Google DeepMind, developed new algorithms for aligning large language models, LLMs, with human preferences. Their approach uses distributionally robust optimization to handle differences in user preferences, achieving a policy parameter convergence rate of O(n) to the power of 4. Researchers at Manchester Metropolitan University and Peking University, along with a team from 3 other universities, developed GPGS. This new method uses Gaussian processes to improve 3D scene reconstruction. It achieves 71% accuracy in densifying sparse point clouds for better 3D Gaussian splatting. Researchers at Tsinghua University and the Chinese PLA General Hospital, along with other teams, developed CDEEP. This new model uses causal discovery with deep learning to predict 6 critical care outcomes. It boasts impressive accuracy, like an AUROC of 0.915 for acute kidney injury prediction, and better generalizability than other methods. Researchers at UC Berkeley developed Flow-Q Learning, FQL, a new offline reinforcement learning method. FQL trains a separate one-step policy to maximize value, avoiding unstable training issues seen in other flow-based methods. It achieved top performance on 73 benchmark tasks. Researchers at Oxford and Ant Group, along with a team from 6 other institutions, explore using multimodal LLMs for time series analysis. Unlike previous work focusing on numerical data, this research integrates text, images, and audio to improve reasoning and go beyond simple forecasting. Researchers at ETH Zurich and Google DeepMind explore adversarial attacks on large language models, LLMs. Unlike previous work on simpler models with well-defined tasks, LLMs present fuzzier safety goals and unbounded attack spaces. A single LLM training run can cost millions of dollars, making thorough evaluation extremely difficult. Researchers at Carnegie Mellon University and Meta created a new synthetic dataset, SynCD, with 95,000 objects, each having 2 to 3 images under different conditions. This improves text-to-image customization by using a new encoder and inference method, outperforming existing methods. Researchers at MIT and Stanford, along with a team from 4 other universities, created the AI Agent Index. This database tracks 67 deployed agentic AI systems, documenting their features and safety measures. A key finding: only 19.4% disclose formal safety policies. Researchers at Tsinghua University and Tianjin University created a fly model to improve AI's continual learning. It uses a fruit fly's brain circuit, boosting accuracy by 22% on CIFAR 100. This model enhances both memory stability and learning plasticity, unlike previous methods. Researchers at Oxford Internet Institute and Google DeepMind explore socio-affective alignment in human-AI relationships. This new research focuses on the evolving psychological dynamics within these relationships, unlike previous work. Character AI, for example, receives 20,000 queries per second. Researchers at Stanford University studied fairness in large language models, LLMs. They found that 32 out of 37 existing fairness benchmarks ignore important group differences. Their new work introduces difference awareness metrics and a benchmark suite with 16,000 questions to better assess fairness. Researchers at Zhejiang University and Microsoft created ReSpark. It uses LLMs to make data reports faster. ReSpark reuses 39 pairs of existing reports to generate new ones, improving efficiency. Data processing choices varied in 1339 cases. Researchers at CNRS and Sorbonne University, along with colleagues from Paris Cité University, present a user's guide comparing sampling strategies for approximating the sliced Wasserstein distance. The study analyzes computational complexity and performance across various dimensions, offering practical recommendations for different data sizes and dimensions. Researchers at Microsoft Research explored LLM's ability to solve sequential optimization problems. They created WorldGen, a dynamic benchmark, and ACE, a Hegelian dialectics-inspired framework to improve LLM performance without retraining. ACE boosted GPT-432K's success rate in simple problems from 36% to 88%. Researchers at Tsinghua University and scientists at Shenzhen Pengrui Foundation developed a new method for medical image segmentation. It uses a pixel-level transfer risk map to improve accuracy. The method showed a 4.37% dice score improvement on one dataset and 1.81% on another. Researchers at UC Berkeley and Stanford University, along with a team from other institutions, developed BARE, a new method for creating synthetic data for LLMs. BARE uses base models for diversity and instruction-tuned models for quality, achieving up to a 101% improvement on GSM-8K compared to using only instruction-tuned models. Researchers at Google DeepMind and KAIST, along with colleagues from other institutions, developed Calibrated Preference Optimization, CAPO. CAPO improves text-to-image diffusion models without using human-labeled data. It uses multiple reward models and a novel calibration method to achieve better alignment with human preferences, outperforming existing methods in benchmarks. Researchers at MIT and Stony Brook University, along with a team from Red Hat, developed Activation-Informed Merging, AIM, for LLMs. Unlike previous methods, AIM uses activation space information to improve merging, boosting benchmark performance by up to 40%. Researchers at the Hong Kong Polytechnic University and University College London, along with colleagues from Hip Yun School, developed VR Mover. It's an LLM-based VR interface for object manipulation using voice commands and gestures. Unlike previous methods, it handles unstructured input, achieving an average response time of just 2 seconds. Researchers at Harvard University developed a new theory to explain deep learning training dynamics. It considers width, depth, and data size together, unlike previous work. The theory accurately predicts hyperparameter transfer across model sizes and depths. Researchers at Google and DeepMind developed a new web crawling algorithm. It uses noisy signals from sitemaps and other sources to update web pages. Unlike previous methods, it handles imperfect signals and adapts to changing bandwidth without central control. The algorithm improves accuracy even with noisy signals, where precision is below 0.2 and recall is below 0.5. Researchers at École Normale Supérieure and EPFL, along with a team from other institutions, developed 2 new spectral algorithms for analyzing high-dimensional multi-index models. These algorithms achieve optimal reconstruction thresholds without needing special starting information. The critical sample complexity, alpha C, varies depending on the link function. Researchers at Google have published a new study on the environmental impact of AI hardware. It's the first comprehensive lifecycle assessment, LCA, of AI accelerators, including manufacturing emissions. They found a 3x improvement in compute carbon intensity, CCI, from TPUv4i to TPUv6e in just 4 years. Researchers at Tsinghua University and Beihang University, along with other teams, created VolleyBots. It's a new testbed for multi-agent reinforcement learning using drones playing volleyball. Unlike other systems, VolleyBots uses real-world physics and a hierarchical decision-making process. They tested 8 tasks, showing that existing algorithms struggle with complex scenarios. They also demonstrated zero-shot deployment to real drones. Researchers at Manipal Institute of Technology and IBM Research used a UNet model with combined simulated and real satellite data, OCO 2/3, Sentinel-5P, to estimate power plant CO2 emissions. The UNet model showed a 330% improvement in R² compared to using only simulated or satellite data. Researchers at Google DeepMind and the University of Cambridge, along with other teams, created string, a new position encoding method for transformers. Unlike rope, string uses Lie groups, working efficiently in 3Ds. In one test, it improved 3D bounding box prediction by 2%. Researchers at Nanjing University and Peking University, along with others, developed MPIC, a new system for faster multimodal large language model, MLLM, serving. Unlike previous methods, MPIC reuses cached information even if the input slightly changes, resulting in up to a 54% reduction in response time with minimal accuracy loss. Researchers at Carnegie Mellon University and UC Berkeley developed Forewarn, a new robot policy steering system. It uses a latent dynamics model to predict outcomes and a vision language model, VLM, to evaluate them. This improves policy success rates by over 30% compared to existing methods. Researchers at the University of Warwick and the University of Wisconsin-Madison, along with colleagues from other institutions, explored double descent and scaling laws in machine learning. Instead of using parameter count, they used the norm of model weights. They derived non-asymptotic deterministic equivalents for L, two norms with high probability bounds, 1NP. Researchers at King's College London and University College London, along with other institutions, used deep learning on computed perfusion maps from routine CTAs, 1393 patients, to predict ischemic stroke deficits. This differs from previous work using DWI, offering a less invasive and retrospectively applicable method. Researchers at Harvard University and Lila Sciences created Dr. MCTS, a new algorithm that combines Monte Carlo tree search, MCTS, with doubly robust estimation. This improves sample efficiency, leading to an 88% win rate in tic-tac-toe compared to MCTS's 10%. DRMCTS also shows promise in complex environments. Researchers at Tsinghua University and the University of Washington, along with colleagues from other institutions, explored how context length affects language models. They developed a new theory using intrinsic dimension to explain the relationship between context length and model performance. Their experiments showed a near-perfect linear relationship, R squared equals 0.9997, between cross-entropy loss and intrinsic dimension in synthetic data. Researchers at Boston University and the Broad Institute developed a new method for evaluating multiple policies under multiple reward functions. It provides pine, delta, pack guarantees and considers all states, unlike previous work. The method's sample complexity scales with a measure of value deviation. Researchers at the University of Toronto and the University of Oxford, along with colleagues from other institutions, present Pandas, a new method for improving large language model, LLM, jailbreaking. Unlike previous methods, Pandas uses positive affirmations, negative demonstrations, and adaptive sampling to boost success rates. For example, Pandas achieved over 97% success, with 64 malicious demonstrations on one model. Researchers at the University of Oxford found that compressing large language model, LLM, text embeddings improves performance on noisy regression tasks. For financial predictions, an optimal dimension of just 8 was found, significantly outperforming higher dimensions. This contrasts with previous research that focused on high-dimensional embeddings. Researchers at Ingéria and Sorbonne Universités developed a new hybrid climate modeling approach. They use generative models to create realistic ocean starting points for existing numerical models. This reduces the massive computational cost, millions of CPU hours, of reaching equilibrium. The method significantly reduces hydrostatic instability in generated states. Researchers at Supertext compared DeepL and Supertext MT systems. They used unsegmented texts and human evaluation at both segment and document levels. Document-level analysis showed Supertext preferred in 3/4 language directions, highlighting the importance of context in MT evaluation. Researchers at Florida State University and Meta Platforms Inc., along with other teams, developed BRIDL, a self-supervised learning framework. Unlike previous methods using single codebooks, BRIDL uses multiple hierarchical codebooks for residual quantization, achieving a state-of-the-art 47.99% MAP on AUD IOSET2M. Researchers at Mass General Hospital and Brigham and Women's Hospital, along with other institutions, developed a new AI workflow using LLMA38B to detect cognitive concerns in 3,338 clinical notes. This multi-agent system dynamically refines prompts, achieving a perfect specificity, 1.00, on validation data. Researchers at the University of Texas at Austin and Arizona State University created a new photonic chip for AI. It uses structured compression to shrink deep neural networks, achieving a 6.87x power efficiency boost and up to 74.91% reduction in parameters while keeping accuracy high. Researchers at Princeton University and New York University, along with others, studied how large language models, LLMs, understand numbers. They found LLMs blend string-like and numerical representations. A combination of string and numerical distance measures explained 72.6% of the variance in LLM similarity judgments. Researchers at Tsinghua University and Shanghai Jiao Tong University, along with a team from other institutions, developed IMD Prompter. It uses the Segment Anything Model, SAM, for image manipulation detection. IMD Prompter automatically generates prompts, improving accuracy and cross-dataset performance. It achieved an average F1 score of 81.36% across 5 datasets. Researchers at the University of Illinois Urbana-Champaign and Google, along with colleagues from TU Wien, developed a new system for automatically generating bug reproduction tests, BRTs. Their agent-based approach, using LLMs, achieved a 28% success rate on real Google bugs, a significant improvement over existing methods. Researchers at the University of Oslo and UiT, the Arctic University of Norway, along with colleagues from EPFL, developed VRLS, a new method for handling label shift in distributed learning. VRLS improves density ratio estimation by adding entropy regularization, leading to up to a 20% improvement over baselines in imbalanced settings. Researchers at Google and the University of Cambridge created MASS, a new framework for designing better multi-agent systems using LLMs. MASS optimizes both prompts and topologies, unlike previous methods. Results show a substantial performance improvement, reaching 78.79% average accuracy across various tasks using Gemini 1.5 Pro. Researchers at Boston University and Carnegie Mellon University, along with a team from Georgia Tech and Stanford, explored using state space models, SSMs, for question answering in Indic languages. This is novel because previous work mainly used transformers. They used a dataset with approximately 28,000 question-answer pairs in Hindi and Marathi to test various SSM architectures. Researchers at IBM and UFRGS, along with a team from City, University of London, studied grokking, a sudden improvement in AI model performance. They found that distribution shifts between training and test data, not just sparse data, cause this. They created synthetic datasets to prove it, even inducing grokking with dense data. Researchers at NVIDIA and Postech created Mosaic 3D, a new model for 3D scene understanding. It uses a clever data pipeline to generate a huge dataset, 5.6 million mask text pairs, for training. This lets them do open vocabulary 3D instance segmentation in a single step, without needing extra labels. Researchers at King Abdullah University of Science and Technology and University of California, Berkeley, developed a new optimization algorithm, the Proximal Point Method, BPM. Unlike the Proximal Point Method, BPM achieves linear convergence in non-smooth convex settings without strong convexity and can find the exact global minimum in a finite number of steps. Researchers at UC Berkeley and the University of Virginia, along with other institutions, developed Encore, a new method for updating large language models, LLMs. Unlike previous methods that struggle after 3,000 edits, Encore handles 10,000 without significant performance loss. It also runs 61% faster than MEMIT and 64% faster than Alpha Edit on Llama 3 to 8B. Researchers at the University of Chicago and the NSF Simons Institute developed a new method to speed up adaptive optimization algorithms. They use the expected gradient outer product, EGOP, matrix to reparameterize the problem, potentially improving convergence by a factor of 1/d. This is different from previous work that focused on other approaches. Researchers at Google DeepMind developed a new model-based reinforcement learning, MBRL agent. It uses real and imagined data for training, a novel image patch tokenizer, and block teacher forcing. The agent achieved a 67.42% reward on the Craftax Classic benchmark, exceeding human performance. Researchers at Tokyo Denki University and AIST, along with colleagues from Oxford, created MoirDB. It's a new dataset of 14,230 formula-generated images for improving image recognition robustness. Unlike previous methods using copyrighted images, MoirDB is copyright-free and cheaper to produce. The results show improved robustness against various image corruptions. Researchers at Independent and Imperial College London, along with others, created AI models with hidden skills. They tested different ways to uncover these hidden skills, using a new model that's more resistant to being tricked. They found that fine-tuning worked best for code generation, while prompting worked well for multiple-choice questions. Researchers at Harvard University found surprising links between new deep learning optimizers and accelerated SGD. They tested these on a massive language model, 150 meters parameters, trained on 15B tokens, showing that ADEMA mix outperforms others. A simplified ADEMA mix version also works great, needing less memory. Researchers at the University of Oxford and Exscientia show standard transformers can learn 3D spatial reasoning using only linear coordinate embeddings. Their model, trained on proteins, achieved a final training perplexity of 6.5, with coordinates vs 11.9 without, significantly improving masked token prediction. Researchers at Oxford and Microsoft Research developed a new method for improving AI teamwork. They introduced expected return symmetries, which learn symmetries directly from agent-environment interactions. In Overcooked v2, this led to a mean crossplay score of 15.8 compared to a baseline of 6.74. Researchers at Tsinghua University and the Beijing National Research Center for Information Science and Technology developed A*STAR, a new multimodal reasoning framework. A*STAR uses MCTS to learn reasoning patterns from just 500 examples. It outperformed GPT-4o on Mathverse with a 7B model, needing 520 times less data and 6.4 times fewer calculations. Researchers at IIIT Hyderabad and TCS, along with a team from MIT and the University of Edinburgh, developed a new framework for robot task planning. It uses LLMs for task anticipation and a classical planner for action execution, achieving a 31% reduction in execution time compared to systems without task anticipation. Researchers at the University of Oxford and Cambridge created CDEC, a new Deep Unfolding Network, DUN, for compressed sensing. They used a continuation technique to warm start a key part of the network, improving reconstruction and generalization performance. The log-cosh loss function was used for training and evaluation. Results showed smoother loss landscapes, especially for CIFAR10 images. Researchers at Stanford University developed a self-improving AI system that generates ML libraries in architecture-specific programming languages, ASPLs. The system uses a novel learning algorithm and achieved up to a 3.9x performance improvement over a single LLM, solving up to 96% of benchmark tasks. Researchers at Oxford and Shanghai Jiaotong University, along with a team from 3 other institutions, present sharpness-aware trajectory matching, SATM, for dataset condensation. Unlike previous methods, SATM minimizes loss landscape sharpness, improving generalization. On ImageNet-1K, where others fail, SATM shows significant improvements. Researchers at the University of Wisconsin-Madison developed LVXATN, a new distributed cross-attention method for multimodal large language models, MLLMs. It reduces communication overhead by up to 93% compared to ring attention, leading to a 5.58x speedup in some cases. LVXATN handles much longer visual inputs, like those from hour-long videos. Researchers at the University of Freiburg and the Norwegian University of Science and Technology, along with other institutions, present a new classification system for combining model predictive control, MPC, and reinforcement learning, RL. This system categorizes existing research based on how MPC interacts with different parts of RL algorithms. Researchers at the University of Oxford and MindFoundry created distribution transformers. This new method speeds up approximate Bayesian inference from minutes to milliseconds. It uses Gaussian mixture models and transformers for on-the-fly prior updates without retraining. Researchers at Cruise and OpenAI, along with a team from other institutions, developed long-tail guidance, LTG. LTG generates synthetic training data focusing on examples a model finds hard. This boosts accuracy by an average of 5.6 points compared to other methods. Researchers at Stanford University and SLAC National Accelerator Laboratory developed a self-supervised learning method for analyzing particle trajectories in time projection chambers. Their model achieves 99.4% track and 97.7% shower classification F scores without labeled data, using a novel volumetric tokenization approach. They also released a massive data set, 1M plus events, 5.2 B points. Researchers at ISPRAS and MSU created a new multilingual dataset for news web page attribute extraction. It includes 3,172 pages in 6 languages from 161 websites. They fine-tuned Markup LM and a multilingual DOM LM, outperforming existing open-source tools. Researchers at the University of Ibadan and University of Cape Town, along with other institutions, developed a deep ensemble for brain tumor segmentation. This approach combines UNet 3D, VNet, and MSA VNet models, achieving DICE scores of 0.8521 whole tumor, 0.8358 tumor core, and 0.8167 enhancing tumor on the BRATS SSA dataset. The study focused on improving performance in resource-limited settings. Researchers at Princeton University studied how memory in optimization algorithms affects training. They developed a new technique to approximate memoryful algorithms with memoryless ones, adding a correction term. This approach works for many algorithms, unlike previous methods. They found that memory anti-regularizes atom W, but not lion. Researchers at Google DeepMind studied how vision language models, VLMs, learn from images and text. They found that how information is presented affects how these models generalize. Across 3 tasks and 3 models, a shape bias was often stronger with image input than text. Textual feature order also mattered. Researchers at the University of Toronto and Ericsson developed ROLO-RA, a new federated learning framework. It fine-tunes LLMs using alternating optimization of LoRa adapters. This improves accuracy and cuts communication costs by half compared to some existing methods. Researchers at Oxford and Cambridge, along with scientists at Spotify, studied wide neural networks. They showed how a new regularizer adds observation noise to the NTKGP model, fixing a previous limitation. A shifted network approach allows for arbitrary prior means, avoiding the need for ensembles. Researchers at Google and Uppsala University, along with colleagues from other institutions, found that reversing the order of gradient updates in deep learning, backward SGD, improves stability and convergence. Using a constant learning rate and small batch size, e.g., 8, backward SGD converged to a point, unlike standard forward SGD, which converged to a distribution. This was observed across various datasets and architectures. Researchers at Sorbonne Université and MIT compared FPGA and GPU performance for particle track reconstruction at the LHCb experiment. They found that an FPGA, Alveo U250, achieved a theoretical throughput of 1.1 million events per second, comparable to the GPU's 820,000 events per second, but with much lower power consumption. Researchers at Harvard and Stanford developed a new X-ray data decoder. It uses unsupervised learning to analyze 109,656 event files, 8 hours each, unlike previous methods that ignored the Poisson nature of the data. The decoder reconstructs light curves and creates useful data representations. Researchers at Irkutsk State University and Lomonosov Moscow State University used convolutional neural networks to improve gamma-ray detection in the TAIGA experiment. They achieved a hadron background suppression of 10,000, significantly higher than previous results. A 5.5 sigma signal was detected from the Crab Nebula in 21 hours. Researchers at LIX, École Polytechnique, and IP Paris developed Fourier-RF, a new few-shot NeRF method. It uses Fourier frequency control to improve image quality. Training takes only about 10 minutes, much faster than other methods. The method avoids high-frequency artifacts common in early training stages. Researchers at Carnegie Mellon University created AMA-Squad, a new Amharic question-answering dataset. It's a translation of S-Squad 2.0, tackling answer misalignment issues. The XLMR model was fine-tuned on this dataset, improving F1 scores by over 7%. Researchers at MATS and Simplex, along with colleagues from other institutions, found that transformers trained on next token prediction use a constrained belief updating method. They used a specific type of HMM, MES3, to show how the attention mechanism creates representations with predictable geometric structures. The attention weights follow a 1-3x-1 pattern. Researchers at Carnegie Mellon University developed a new way to make better depth maps for self-driving cars. They combined cheap camera images with 4D radar data using a special spectrum method. This improved accuracy by 27.95% compared to the best existing methods. Researchers at the University of Cambridge developed a new method for optimizing 3D printing. They used 4D neural fields with a novel gradient-driven regularization. This improved smooth interpolation between different flow rates, leading to better geometry predictions. The method was tested on 36 printed parts, achieving improved geometric fidelity. Researchers at Kosminski University and MIT created a new framework for evaluating AI in dermatology. They found major inconsistencies in existing studies, like pre-split data augmentation. Their framework uses DINOV2 large on 3 datasets, achieving macro-averaged F1 scores of 0.85, 0.71, and 0.84. Researchers at the University of Oxford developed FABPI, a new method improving prediction-powered inference. It uses prior knowledge about prediction quality, resulting in smaller confidence intervals when predictions are accurate. The horseshoe prior makes it robust to poor predictions. Researchers at the University of Oxford and Meta studied how to measure moral values in languages other than English. They used Chinese and compared machine translation, special dictionaries, and large language models, LLMs. LLMs, like Llama 3.1, performed best, reaching an F1 score of 0.86 after fine-tuning.
That's the end of today's paper highlights. Great job you made it this far. Now go conquer your